technological indifferences. All right, so started recording. Perfect. So I think when I was so rudely interrupted, I was right about here. Can everyone still hear me okay? My sound good?
You seem to be off a bit.
How about that? Is that better?
Sometimes you're really loud and sometimes it's really faint.
It's probably the closer and farther away I sit from my microphone because it seems I move around a lot. So it probably got a little bit louder there as I moved closer. Try and sit closer. So
Yeah, that sounds better.
doesn't change as much. All right. So I was talking about warranty and failure analysis, I think is where we were at. For those of you who are doing warranty failure analysis, it can be something that's important. And it's basically finding out why something failed so we can stop whatever the cause of it was, whether it is possibly something is misspec'd where it is operating, or the operator is doing something incorrectly, or it's overloading, whatever the case may be. Okay. So bearings are going to give us very distinct signs of why they fail and what caused those failures. Things we're going to be looking for, where we're going to be looking for them too. I'll be showing you in the shop. It's much easier to see. But we're going to be looking for corrosion, cracks, anything obvious on the bearings that is physical damage. We'll take a look at in the shop too. I have some good examples we can look, and how to look at the elements and the races, because sometimes it's very difficult to see the rollers because they don't come apart. It's a one-piece bearing, so tapered roller bearings. You can only really see that in a race if you can look through the rollers and you have to move around. So it's very, very important to look at all of those. Main failure types of failures that bearings experience. These terms are going to be common throughout all of your trade school. So you're going to talk about these terms again in second year, third year, and fourth year. Peeling, spalling, Brinelling, arcing, and fatigue. We've probably seen some of this already. If you've taken a wheel end off and you take a look at that race and you've seen some peeling like this. So most of the time you're probably taking that wheel end off. Why? Why would you take it off?
The seal's leaking.
Yeah, so what would that cause? Insufficient lubrication, of course, right? Trailer hub has very little oil in it, so if that oil leaks away, it does not take long before you can get peeling damage to start happening. Now, if you continue from peeling, you're eventually going to have chunks going like this. These bearings would make a hell of a noise. You would know that there's something wrong with that wheel end just by the sound of it rolling. Very rough as well. So Brinelling, this is something that's a dent in the actual material. It's caused a few different ways. The one we talk about in first year is the way we can cause Brinelling, and that's by impacts. So the way we install particular bearings could cause Brinelling, dropping it while we're moving it around the shop, and also shock loading machinery causes Brinelling. There's also what's called false Brinelling, and that's going to be this. It's going to look the same. There'll be little dents inside of the races. It's just caused a little bit differently. So ultimately it looks the same. Now arcing is going to be, if you do any work with a welder, it's potential that could happen. Typically for us, because bearings are where we see them in wheel ends is a lot of it, and we typically aren't going to connect a ground cable to a hub and then be welding on the axle. You always want to put your ground very close to where you're welding so you don't have the current traveling through anywhere you don't want it, essentially, right? Now what
You can get that from Cork and Tracks.
Yeah, okay, from working on tracks. Yeah, if you put your ground somewhere while you're putting the growlers on tracks, right? Welding those back on. If you put your ground in a place that's maybe a bit far away, right? So that you don't have to move it every time you roll the track over. That might cause that, absolutely, yeah. Essentially, all it is the current is traveling from one race through the roller, the very small contact on the roller, to the other race. And what that'll cause, it's just a little tiny electric pit inside of the races, okay? And it's just from the spark. It's gouging out little pieces of the steel, burning it away. So fatigue is just what's going to happen after it starts to break up. If you, the largest killer for bearings is operating above their load rating and speeds. So high loads and speeds are what's going to cause fatigue really, really quickly in a bearing. The other thing that is a huge problem for bearings is failure-wise is oil, lack of lubrication. That's the other one that's going to cause it. And then the last thing you need to worry about is contamination, okay? This is a really bad one, and it has to do with seals. So those are the different ways that you can have your bearing failing, okay? Now we'll move on to the seals. So contamination will kill your bearing. If you get contamination, chances are you're going to end up with this type of wear. Lots of contamination in there will start spalling happening quite quickly. So your seal failure, a seal fails, you're going to get, well, seal failure will involve ingested contamination. So something will get inside that shouldn't have been, that the seal should have kept out. The other source of contamination comes from us. So when we're installing in a very, very dirty bay and we're not cleaning properly, not cleaning bearings properly, it can destroy them. It only takes about a tablespoon of contamination to run through like a transmission, and it'll destroy all the bearings inside of it, okay? And as well as a bunch of gears, and it's very, very bad. How do we get contamination? Well, a lot of it comes from where we're operating. So this is a good point when it comes to why do we use air brakes in our industry? Anybody? It has to do with the connecting and disconnecting. So there are some units out there that have hydraulic quick disconnects, and they tend to be on components that have very high tolerances, higher tolerances, I suppose I could say, because it's about contamination. An easy way to get contamination into things is, for instance, if you had to go check drive axle oil on a unit that's out in a dusty area like this, and you don't clean it off properly, then you pull the plug out and a whole bunch of dirt or sand or something goes into the hole. So test ports are a common one. Another one is if you do have quick disconnects for hydraulics and you're not cleaning them off properly, when you connect and disconnect, you can be ingesting contamination, and eventually it'll get down to your into components, because it will be after the filtered oil will have happened. So seals, we talked about how seals don't necessarily hold the pressure, and we have our vents that we need to vent out the excess pressure. They also do something else. So first of all, why does pressure build up in these cases? Why? Heat, yeah. So heat's generated when the bearings are turning around and around. The oil heats up, some of it vaporizes. As all that's happening, the gas inside of there is heating up as well, and it's expanding, okay? So that pressure needs to escape. What happens when everything cools back down?
Shrinks.
Yeah, it contracts again. Everything will get smaller again. So we need a way to allow pressure to come back in, okay? Or Yeah, essentially the pressure to equalize. It's going to want to equalize at that point. Once the temperature comes back down, the pressure is going to start coming back down as well. And it's going to want to equalize with the outside. So if our vents are clogged and our seals started letting out pressure, but it held a tiny little bit in, as it cools down, it's going to start drawing in gas contamination that ride around the dust seal. So remember, our lip seals that we're going to be using mostly have two lips on them. One side is to keep out dust and the other side is to keep in the pressure. So if you start having a drop in pressure in here, a low pressure, it's going to start pushing in and the contamination will be drawn in with it. And that can be anything from moisture to dust. Even we have a lot of problems with moist, very humid air, right? And or you can some days. It's typically a lot drier here, and it's not like on the coast, either of the coasts, where you would have really humid problems. That leads to totally other problems to worry about. But out here, it can get humid sometimes, especially on a cold day. You run an engine outside in the middle of winter, it gets really hot. When you turn it off, it draws in a lot of that humid, cool air, and everything condenses on the inside. Or in hubs too, you run hubs a little bit too warm and they draw in a lot of moisture, and then you end up with milky looking hub oil. Pitting and bruising. So if we get contamination, here's the start of what's going to happen. They call it pitting and bruising as opposed to the spalling that happened at the front, because they're caused by slightly different things. So the spalling here, no lubrication. Pitting and bruising, contamination. Now I've seen either you can get spalling damage from contamination, but you won't get this pitting from lack of lubrication until it starts coming apart. So if you have this pitting and low lubrication, it's already starting to break away. And there's the contamination essentially is the bearing itself is what's happening. So this etching is caused by moisture. So a lot of times if you have a unit that drives out to site, sits there for a long time and then drives away, it's going to have this rust etching that's on these bearing surfaces. What I have seen in the past, depending on how bad this, oh, I froze, there we go, how bad this etching is, sometimes it's just a little bit of surface oxidation. And if you can clean it away with a rag and some brake clean, it's probably all right. But if it doesn't clean away and it's changed the surface finish of this, the bearing's garbage at that point. How do we take bearings off? So there's the two main ways we're going to talk about is a destructive method and non-destructive method. So for all of us technicians out there, which is all of you, the destructive method is probably the one you're most familiar with. That is the way we're taking the bearing off. We know we're not going to use it. We don't care what it looks like when it comes off. So hammer, torch, grinder, chisel, air hammer, all kinds of destructive methods of removing, okay? Typically, we're not worried about the bearing because we're changing it, but we are worried about whatever it is we're removing the bearing from. That would probably be something we would be concerned about, even if we're using a torch or a destructive method.
Good one. One is like a hanger bearing.
Yeah, hanger bearing.
Yeah, I usually cover it with a rag and then smoke it with a hammer and let it crack, and then I have to torch off the other side. You got to be really good with a torch.
Yeah, I can talk about steady bearings or hanger bearings as well. They're a good example of that, absolutely. So all of those destructive methods that we use, so torch, hammer, maybe not a grinder, but a lot of those can easily become non-destructive methods depending on how we utilize them. So instead of using just a torch, we can use actual heat. And if we're evenly heating, it won't necessarily be destructive. Now, they're going to say you shouldn't ever heat a bearing past 250 degrees, and that's even just during operation, okay? You don't want to heat this bearing red hot. It's going to change its metallurgy, and then the bearing's going to fail prematurely anyway, okay? If you are going to heat it, you should limit the amount of heat, only the amount necessary. Shouldn't change the color of these bearings while you're heating them like this. A press.
What was that tool right there? What, I wasn't sure what I was looking at.
Oh, okay. So what this is, it's called an induction heater, and they sell a few different types of it. I can actually, at a little bit of a break time, I'll show a video about these. They sell, the one that they sell that's common now, it's a handheld, oh, my pen's off. It's a handheld device that looks like this. And out of it comes a coil, almost like from an old style oven. So essentially, yeah, that's a good way to describe it. This is like an old stove, an old stove top. These are heating element rings. And what they don't show you here is somewhere there's going to be most likely an electrical cord on this that plugs into somewhere. So these heat up like an old stove does. Does everyone know what I'm talking about by an old
Oh yeah, I see what
stove? Yeah. If not, I'll have to take you to show you mine because I have one. I'll show you what it is. And that's essentially all it is. This one, this smaller one here, they design it and they have different forms of this element that you can bend. So it's supposed to essentially be a flameless torch. So they say like you can heat one nut without putting heat on anything else. So
right.
I'll find a little more information on it. This picture is probably a little bit old and very specific. They look a little bit different nowadays. So a press, they say a press is a non-destructive way of removing a bearing. I slightly disagree with that because you have to be very careful. So if you did want to remove this bearing from this shaft with the intention of reusing it, you'd have to be very careful to make sure. So what is pressed onto the shaft? The inner race is. So you need to make sure that is where you're applying the force, on the shaft and the inner race. If you apply force to this outer race through the rollers onto that inner race, chances are the bearing is going to come apart and it won't be reusable at that point. So a couple of things. Read all of these dangers about a hydraulic press or an air press or whatever kind you may have. They can be very, very dangerous. And I have a good video about bearings coming apart in a press. They are very dangerous if that happens. The other danger about bearings is, yet again, I'll talk about it. It has to do with those thrust bearings, seal installers, and those coming apart as well, okay? I'm hoping most of you have something like this. Might not be air, but it might be just a bottle jack that's turned upside down, even just some sort of manual one that you pump by hand, okay? Something like that. That makes changing bushings very easy. Make sure if you are doing a bearing though, you're supporting the correct position, okay? That's all there is to it really. Use all the safety cages, pull on the correct portions. So just like what I was saying, just like if you're going to use one of these jaws, you want to pull on the inner race, even though you don't intend to use these bearings again. They know that you're not going to get it perfect, okay? And I mean, realistically, if you're taking the bearing off, chances are it's because it failed and you're not reusing it. So very rarely would you be removing a bearing that's pressed in place for no reason other than to change it. So this one C, this internal puller, this is how you can change countershaft bearings without taking transmissions apart. Pretty common. Auxiliary boxes, same idea. Might end up doing something like this. Okay. That's where I've seen these. These I've seen in smaller agricultural applications, where I've seen shafts like this where you're removing bearings, but not so much in on-road tractor trailer stuff. For some installing some seals and bearings, a set like this might work. Okay. These slide hammers come in handy, and I will show everybody in the shop how we can use slide hammers to take seals off very nicely and bearings out as well. So it's going to be very specific cases where this image is from a very specific circumstance where you need to remove this internal bearing, and these expanding collets will be specific sizes, and you'll have to use the correct one with the correct range in order to get in there. So it'd be a very special kit that would have these in there. Slide hammers are fairly common, but it's just this collet that would expand, be very specific. For us, a lot of the seals that we're going to end up seeing are the larger Stemco seal drivers, okay? Those, I mean, the company gives them to shops typically for free, and just make sure you pick the correct one when you're installing the seal. So destructive methods, here's where we'll talk about torching and cutting. So this side of the race is fairly easy to remove, okay? You can cut this fairly easily without worrying about damaging the shaft. You can cut the other side, that'll come off. Cut this cage and the rolling elements will fall right out. Super easy. Now here's where the skill comes in. So here you're removing with a grinder. They're just gonna keep grinding down slowly, slowly, slowly. And I'd probably bet that eventually they're going to grab a chisel and they'll crack it right there. Or if they are very skilled, they'll go and grind all the way down. Now, when it comes to torch, we can see, so a steady bearing or a hanger bearing is the one on the drive shaft that's holding the drive shaft up onto the frame before it drops down to the drive axles. So what whoever it was talking said is that in order to remove these, he's using rags and you have to be very quick with the torch. And he's absolutely right, because it will be pressed on the shaft just like what this one is here. So my tips for using the torch when you're cutting this thing off is work fast and only put the heat where you want to cut. So what you can do, if you work quick enough, you get your torch and you start right, I'm gonna make this way bigger. You get your flame, you start right over here. Okay, as soon as this turns red hot, you hit the oxygen to it and it's gonna start separating apart and blowing apart. And you just move backwards, nice and steadily, and you will see the cold steel underneath as it starts to open up. And it, with a very thin race like that, it really doesn't take long to cut through it. It doesn't take much, okay?
That's exactly how I do it.
Yeah, and if you go nice and steady, I'm not saying just quick, but once it starts going, you just steadily let it go and don't hover in one spot for any amount of time. You should be okay. So those are my tips.
You should burn that top or that bearing before you touch that thing, so you don't want to be around for a long time at all. Anyway.
Yeah, and if you did have to put heat on this, like if you tried to use heat to get this red hot to try and get it off and it wouldn't, don't try cutting it right away. The heat that you put into this race is transferring into this shaft. And if you put the torch to this, they're very close in temperature. And because they're touching, they will both burn away really, really quickly. The idea behind moving fairly quickly is that the heat is going into the thinner material and it doesn't have the chance to transmit into the thicker, larger piece of steel. And you're cutting the smaller one away faster than it can transfer heat. So that other piece should be quite a bit cooler. But yeah, if you've put heat to it for a long period of time and you go cut it, it's all just gonna turn to slag right away.
What's that, Ryan?
So this is the the spindle on my wife's car. She's got an Altima. See, the big bearing in there is pressed into the actual spindle, and so I had to knock the center out, and then actually cut the race. Hold on here. There it is. I actually, once I had the center knocked out, I actually had to cut this race with a plasma cutter to get it to release from the inside. And then when I was done, I put the bearings, they were in the freezer the whole time I was working on our car, and I was able to press them in when they were cold and the spindle was hot.
Oh, nice. Right on. Thanks. Same idea. That's exactly it. You're basically an expert in removing and installing bearings. So the opposite of heating things, cooling them, throwing things in the freezer, like you said, keeping it in the freezer, or for us, sometimes in the middle of winter, just keeping it, storing them outside, right? Works very well. Yeah. So give me one moment, please, everybody. Hi, sorry about that. All right, let's keep talking about breaking things. Anybody have any questions?
Nope.
No, okay. So cutting torch. This is actually, I didn't realize this looks like the same bearing I was just showing you the picture of. I didn't realize it's so small. This will cut through here in no time. And I would definitely don't heat this up and then do it. Just
Screensaver or screen.
screen share, right? Thanks. How about that?
Yep.
Perfect. So yeah, this looks like the same bearing. I would definitely not put very much heat in there. It won't take long at all to cut through that bearing, okay? Looks like an input shaft. Here's a good idea. Anytime you're cutting something with a torch, have a fire extinguisher nearby. The other important thing what should you make sure with your fire extinguisher?
That it's the right one.
And it's charged.
Yeah, that is charged. I may or may not have been torching underneath of a tanker, and we had a fire start, and the fire extinguishers in the shop were not charged. And so that is a very fun run around the shop to find one that is charged.
They're supposed to be monthly inspected.
Hey, yeah, they are. And you know what? If you use a fire extinguisher, don't not tell anybody. Please tell somebody so they can get a new one, figure out why the fire happened, what you could do to prevent it in the future, and also get a new fire extinguisher, okay? Don't hang the old one back up, because if somebody isn't really checking, it could just, oh, there's a fire extinguisher hanging there. So it's a good one, because in a panic moment, that's not the time you want to find out that it's not good. Yes, someone want to say something?
Lot of paperwork once you use the fire extinguisher.
What's that?
Lots of paperwork because you need to report it on safety that you use the fire extinguisher.
Yeah.
A lot more paperwork, and there is a fire. You can't put it out.
Yes, there is definitely a lot more paperwork if there's a fire that you can't put out. And either way, you get paid by the hour, right? So if paperwork's part of your job, well, that's just the name of the game, right? So sometimes it's you definitely would rather fill out the paperwork than not have a fire extinguisher that's charged, right? So I skipped over this because I don't see too many people using this very often. A split sleeve now with welded lugs on it to drive bearings. Has anyone ever had to use this? I know there's some people out there, it might be difficult to talk, but I'll keep looking at the chat too, but I don't see many people doing this. What the idea of this is, and they don't show it very well here, because in this you would think, well, why don't you just use a pipe, right? Like, look at how this piece is. Like, why couldn't I have just slid this over? Why is it split? But the idea is that there's something on here that you can't take off, and this is the way it needs to drive off. And so you have this split sleeve, and I mean, they have it here, like this is a classic mechanic tool, right? Held together with wire to hold it together. Will this work? Absolutely. Is there a different way? Most likely. Yeah, there probably is a different tool or driver, okay? Yet again, when you're using any kind of punch, drift, sleeve, driver, and this is the perfect picture for it, you need to make sure you're driving in the correct area. If you had any wish of reusing this bearing again, you need to make sure you're pushing on the correct race. If it's pushed onto a shaft, it's this inner race, and if it's driven into a bore, then for instance, if it were pressed into a bore like this, you'd need to make sure you're pulling on this race if you would want any hope of saving it. Welding. So here's how you can absolutely remove a bearing, and definitely it won't be reusable. So this is a common one for aluminum hubs with steel bearings.
Yeah, I've done that. Even with steel or races inside of a diff, that after you pull that inside bearing off, that you got to change because it's too loose.
Yep, that's it. Yep, this weld is perfect in there. So what they're doing with this heavy bead of weld in there, it heats everything up really nicely, and then when it cools off, it sucks the bearing in. Okay, it is really, really good. Then there is another trick you can do once you've gotten these bearings and races out if you don't have the proper driver, and we'll talk about that too. So here, this one, what they've done is welded nuts in here, and then we're going to use a puller to try and attach to it, and then it can thread into the shaft and pull it out. Either one of these, the bearing is obviously no good. You just filled it full of weld, like it's definitely no good. So cleaning bearings, if you're gonna take a bearing out, clean it off, you've inspected it, and it looks like it can be reused, you need to make sure you've cleaned it properly. Never ever spin a bearing with compressed air. You can absolutely use compressed air to blow on a bearing and to remove solvent from a bearing, that's fine, but never let the bearing spin while it's under with compressed air, or you risk the same injury that you could get with incorrectly using a press on a bearing. It'll come apart, and it's basically like a gunshot. All the rollers will come flying out, and they go really fast, and they're quite a bit of weight to them as well. When we talk about brakes, we'll talk about weight. And if any of you are, I don't know, hunters or sports shooters of any kind, you'll know the relationship between mass and velocity, and having very heavy bearing rollers come at you very fast is very, very dangerous. So yeah, so for your initial cleaning, I use, a lot of times just a can of brake clean to spray the oil off to take a look at them, but you want to have a clean tank too. That's where you're not putting huge amounts of sludge in, all right? You want to try and keep these bearings clean. And that has to do with your machines. So I've seen some really, really nasty looking solvent machines, okay? Or parts washers, or whatever the case may be. And how we keep those parts clean is beyond me in some aspects, but we have to figure it out. So have to keep them clean. And now when we're lubricating bearings, a lot of times for us it's going to be oil lubrication. So typically we install bearings and they're going to have an oil film on them. It's pretty standard. If it's a grease packed bearing, it's a little bit different. We have to make sure we're packing them correctly. But oil filled or oil lubricated bearings, typically we install them so they have a little bit of oil in them. And then once we top up the reservoir, that's going to sufficiently oil those bearings or supply oil to the bearings. Any bearings that are grease, that are permanently sealed like this, typically you're not repacking them. Now, have I seen some weird things done? Yes, I have. Is it the best? No. But sometimes in a pinch, if you've got to turn this grease bearing into an oil bearing, it might work to get you home, kind of thing. So the absolute most important thing, and probably I'd say it's a handful of you who've never had to pack a bearing with grease by hand. This is what our typical roller bearing looks like, and this is something we can talk about in the shop as well. I need to make sure that between every roller, so right here, I have the rollers here. Okay. In between each roller, I need to see the grease coming out of each one. Okay. We need to see grease coming out of each roller, or in between each roller. If it's not, it's insufficiently greased. Some of you have probably seen this. So it's a
mess, but
it's a mess. They work though. They can work.
yeah, they work.
Yeah, different versions of them. This one's threaded. So as you rotate this plate down, it forces the bearing into this cone, which is forcing grease up into it. You can see the grease is coming out. It's underneath of the cage there and coming out in between each roller. Very important. That's where we want it to be coming out. Okay? So cold mounting, what they're talking about is just driving it on, okay? different types of installers, arbor press. So this press even works too. If you have one of these, it can help you out. These hydraulic press or an air press, something to that effect, works a lot better. The other thing you can do, and this is for wheel ends specifically, if you don't have a driver for a bearing race, use the old race. Now the problem comes is, well, you're driving a race with a race that's the exact same size. So you run the risk of jamming it in the bore or on the shaft as well. Okay? Or in the bore, I guess is what I'm talking about. So you have your wheel hub and you want to drive the bearing into the bore here, but it's the same size as the other bearing race, right? If you take your bearing race, the old one, you take a nice and decently thick grinder disc, cutting disc, you cut into the bearing. As soon as you take that grinder disc out, the bearing will shrink in just a little bit. And it'll be just enough so that it'll still sit very nicely on the race of the same size, but it won't get stuck in the bore. It's just small enough. That's how I would get around that problem, or how I have in the past. So remember, what kind of damage can we cause if we're doing this and pushing on the incorrect place?
Get little bullets flying at you.
You can, yeah. What's the other type of dent damage? What's it called? It starts with a B too.
Brinelling.
Brinelling, absolutely, yeah. So this is how you cause brinelling, is if you are driving on the incorrect race. And these pictures are so small, it's a little bit hard to see. So he's driving this bearing onto this shaft. You can see it's the tool is pushing on the inner race. Here we have it's driving this bearing into the bore. So you can see the tool is pressing on the outer race. And this is where you'd want to make sure that this tool isn't going to get stuck in that bore, because then you have a whole other problem of worrying about getting your stuck tool out. Now, this one, a bit of a special circumstance. So what they're saying here is this shaft and this bore housing here, both are in place. And this bearing is driven or interference fit on both of them. This tool sits on the inner and outer race. It doesn't sit on one or the other. It's driving on the full surface. And all these are talking about is two-piece bearings that can be in certain applications. What I've seen with these, so where they are typically is off-road equipment and agriculture. I don't see many of these in on-road stuff. Or I guess in the components that have to do with driving on the road and hauling weight. So like your typical tractor trailer with a van trailer on it wouldn't have something like this anywhere. Here is a very nice way of trying to install. Where did we said we see needle bearings? Most common place is probably U-joints. So when you're installing that trunnion in the U-joint, typically it's not a press fit in there, but it's a press fit in the housing, okay? So you want to make sure when you're driving the cup into the housing, just like what they're doing here, that the trunnion is still inside of there. None of these needles are going to fall down, or if they do, you pick them back up, because if you try driving the trunnion in there, then it's going to, I think you said it broke the needle, and that's absolutely, the needle will break. Sometimes they lay down flat in the housing, and then the trunnion won't go in all the way, and you're fighting, thinking, what the heck is going on?
That's what happened. The needle fell into the bottom and I broke it.
Yeah. I mean, it will, I've seen people work really, really, really hard to break it, and I've done it myself too, right? You're sweating, huffing and puffing, thinking the more frustrated you get, the worse everything's getting. And why is this taking so long? What's going on? It won't go together. I don't understand. And then it breaks, and you just spent a whole lot of energy really mucking it up. So it can happen. What I've typically done when it comes to U-joints, try and take it to use some sort of guide, use that trunnion as a guide while you're driving it in, okay? So you have to have the U-joint installed anyhow when you're installed, like it has to be in the yoke in order for you to start putting the cups in. So try using it as a guide, and that'll keep the rollers in place.
If I ever drop it on the ground or something and for some reason the needles fall out, I usually grab a fingerful of grease or something and just try to get a little bit of stick on there and let it slide off.
I've done it too. It works. It works. And I mean, that unit didn't come back with a broken U-joint or anything like that. So how do we mount bearings with heat? Now, very, very, very carefully. So the numbers we use here, 121 degrees Celsius. I said 250. 250 degrees Fahrenheit, okay? So 120 degrees Celsius or 250 degrees Fahrenheit are the maximum temperatures. There's a bit of a different one for sealed bearings. I've never done a sealed bearing like this, so I mean, I don't even know how common they would be. Bit of a lower temperature involved with those though. Does anybody have anything like this at their workplace where you're heating bearings in oil or in a heating cabinet?
No.
No. So this one is using similar technology. It's called an induction heater. So this is just like that stove type of deal, or a little bit different than the stove, I guess. It's used electrical current to induce. So through induction, it's causing the heat to happen in this bearing.
But they're actually hot, like if you were to touch them with your hands.
Oh yeah, yeah, they are.
So you could just do it on a regular stove.
Yeah, essentially it's all about even heating is what it is. I would say if you're gonna do it in the oven. So oven probably is more evenly distributed than just the stovetop.
Okay.
Yeah, because that would be more like a cabinet. And that's just like this too. So there, in this one, it's oil suspended, right? The idea not having it on here is because this is where all the heat is concentrated and coming out. When it's in the oil, it's evenly distributing it. And that's the same thing with the oven, is it would be sitting in the air that is evenly heated, or more evenly heated than just putting, right? Because you have the hot oven or stovetop, and then you would put the cold bearing on that. So it would heat on one side first and then the other side eventually. And so you'd have one side that's hot and one side that's cold.
Gotcha.
Yeah, and so they're trying to evenly distributed heat, and even heating is what the idea behind it is. The other thing you can do is microwave a bearing.
I don't know if I'd do that.
Well, I wouldn't do it in the one that I have lunch in all the time, but maybe I'll get brave and I'll actually show you that you can microwave a bearing and how to do that carefully. But you can microwave a bearing. Don't go and microwave a bearing right now though, because you'll probably wreck your microwave. Not something I'd recommend doing, but just for fun to know that you can. So this stuff, temp stick, not only is it good for bearing and monitoring maximum temperature, it's also very important for when you're working with things like frames and springs. This is going to tell you how hot you're getting different material. Clint might have talked about this a tiny bit in his metals and materials one. So this is how different, depending on what you're manufacturing, how you can heat something up evenly to know when you start or how quick you're cooling it down, okay, to get different properties out of the metal. So in this case, we're going to put it on the bearing to tell us when the bearing is approaching that maximum temperature, okay? So because we don't want to heat it beyond that. Bearing adjustments. So some of the things to consider, all anti-friction bearings need to be set. In some way or another, there's going to be a way that we can measure the limits on them, and they're either set by us or they're set at the factory and we can't change it, but in either way we can measure it. So things that we need to consider when we're installing bearings or picking bearings: speeds and loads, and then conditions and temperatures. Especially for us, we're deemed an extreme environment. The temperature fluctuations go from minus 30 degrees Celsius to plus 40. And I mean, really, it goes from here in Fairview, you can get minus 45 to plus 38 degrees Celsius, right? So we're considered an extreme environment. Maybe not on a day like today, but in the depths of winter or in the bleaching sun of summer, it can be an extreme environment. So those are all things to consider when we're picking bearings and adjusting them. So when a bearing is installed, if one is operating under extreme loads and high speeds, it's not normally preloaded. Okay. What is preload on a bearing though? Do any one of the 4 or 5 people who talk wanted to guess?
If a bearing is designed for thrust, like side thrust, it would be the fastening device pushing on it to put pressure on the elements.
Yes, that is preload. Yep. So here's a good picture right here. We'll look on this one. I'm going to make it big. So this outer portion is the hub here. What we have is the adjusting nut, just like what you were saying. This adjusting nut is pushing on this race. Okay, and remember when we talked about transfer of force? So the force is being applied onto this race. Oh, I am red too. And then it goes up through here into this race, which pushes on the hub itself, which is then pushing against this race, down into this roller, in through this race, and back onto the piece where it can't go any farther. So what the preload and end play are, so there's 2 things. Preload and end play. It is a lot harder to write than I would think with this. And end play, there we go. Preload and end play. So preload is the complete lack of end play. So, and end play is the space between these rollers, or here, or here, or here, or here. I wish I knew how to change the color of the pen. So end play, ideally, we only want it to be the space in between the roller and the race. when we put a bearing together, there's a very small amount of movement that can happen. And the tighter we make this nut, that removes all of that space. And eventually, there won't be any left. We would call that we're at zero end play. And what you would find is that this hub, if I tried to move it this way or this way, there would be zero movement. So nothing whatsoever. 0.000 thousandths of an inch. No movement. That would be zero end play. Now, in order to get preload, we would start tightening the nut more. As we start tightening the nut, we're not losing movement. We don't get negative movement. What we end up getting is a resistance in the way that this hub will turn. So the tighter we make it, the more preload, the more force it'll take to rotate this hub. Does that make sense?
Oh yeah. So you can wreck a bearing obviously doing that though if you go over tight or not really?
Oh yeah, you can wreck a bearing really quickly with too much preload. You can also wreck a bearing really quickly with too much end play. So now, the opposite of this, if I start backing this nut off, all of the space in between here and here and here and here will start getting bigger and bigger. And eventually it'll start from that zero end play, and I'll be able to first move this maybe 1/1000th of an inch backwards and this way. So in total, it moves 1/1000 of an inch. If I keep loosening it off, eventually 2 and 3, 4, and eventually it'll get as loose as the bearings allow before they start unseating from where they are on the shaft and in the housings. Okay. If you think of a wheel hub, these races are driven into that hub. They won't be moving, but these ones slide onto the hub, onto this spindle here. They slide on. And so if you keep loosening this nut off, you can get this full amount of movement, and it will be from the races themselves sliding back and forth. So you could eventually get a 1/2 inch of end play, which is way too much and would damage this really quickly. So on a wheel end for us, tractor trailer people, and what bearings we are going to be setting here at the shop is trailer wheel ends. And this is still typical for drive axles as well as steer axles, is to want 1 to 5/1000ths of an inch of end play. So 1 to 5. Oops, that is a weird 5. 1 to 5/1000ths of an inch of end play is what ideally you want. So too much end play will cause it to be loose and rattly, which will cause pitting and damage to the bearing, and it will come apart and it won't be good. You'll end up denting them from the impact loads. And we'll talk about why that is too. There's essentially a lot more space for it to accelerate. So before it actually makes contact, and that additional space creates too much force, which causes dents. Now, the opposite, if we have it too tight, you're going to get that peeling. It's going to cause way too much heat, it's too much friction, insufficient lubrication because there's insufficient clearance for the lubricant to get in between the rollers and the races. And so that's going to cause that peeling. It'll make clearance, is what you've probably heard it say. If you make it too tight, it'll grind its own clearance. They're absolutely right. It'll machine it down at the cost of the bearing life. So I wish I could be in classroom and show you some different examples of this, but I think in the shop is where I'll be able to show everybody.
They have those cones now too, so now they're kind of dumb proof.
Oh yes, the spacers. And if you look, I didn't talk about it, but there is one right here. No one else mentioned it either, and I was happy because I could talk about my example, but now that you pointed it out, I'll mention it. What this spacer actually is doing right here, this orange piece, it is stopping these two races from coming any farther together. So essentially, you tighten this nut up to a certain torque value, and the end play should be set. It's just a matter of you measuring it to confirm it. And those are those ConMet hubs. They work great. They make one that's called a preset hub. If you work on a service truck and you go out and see tractor trailers out in the ditch, stock those for trailer and drive axle hubs. They work so well. It comes with the bearings already inside of it. The seals are inside of the hub. You literally just take everything off of the spindle, clean it off, and then slide this hub on and torque the nut. That's all you do. And then fill it up and it's like done. Put the hubcap off, on, drum and wheels back on, and it's ready to go. No, there's no fiddling around with taking seals out, putting seals in, and it's fairly inexpensive actually, especially for service truck work. So, okay. So how do we check for end play? The way we can check for end play is with the dial indicator. How would we measure it on this? Couple different ways we could measure that end play. So you're basically measuring the difference in motion between the hub, which is this white piece, and the spindle, this green piece. You want to know how much movement relative between the two pieces there are. So you can put your magnetic base on here, and the dial indicator can go here. Or the exact opposite works equally as well. You can put the dial indicator here, or the magnetic base, and then the dial indicator here. And then all you're doing is pushing and then pulling all the way. And you want to see the total amount of movement from one stop to the other. And that's your measurement of end play. Now, preload. So it is set by using spacers, shims, threaded nuts. So it's set the same way. It's not the clearance. It's the amount of force, how tight we make that rolling element. So how tight it's squished in between the rollers. How do we measure it?
Pulling in and out on the hub really hard with the dial indicator there.
That won't measure it at all.
A fish weight scale?
Yes. So right here, first of all, why wouldn't a dial indicator measure that at all? And pulling in and out of it as hard as you can.
Because you're measuring the resistance on the bearing itself.
Yeah, so you're measuring preload. The only way you can measure it is the resistance of the bearing actually rolling. Once you're a bearing, so here's the best way to put it. A bearing that has end play doesn't have any preload. Does that make sense?
Yep.
And a bearing that has preload doesn't have any end play. They're essentially, you can't have both of them. Now, does a bearing with end play have rolling resistance? Of course it does. You can't ever remove all of it, but there isn't any additional rolling resistance because of the preload. Hopefully all that makes sense. So the pushing in and out of it, we wouldn't be able to measure it because whether it's at 1 pound of preload or 100 pounds of preload, it's going to have 0 end play, which is what you're measuring with this setup here. So what you would do, just like what whoever said, a fish scale, perfect. If I was looking at this assembly from the side, I'd have the hub, and then I'd have my spindle in the center, and the bearings around here, this in the bore. What I'd want to do is I'd want to attach a fish scale and wrap it around here a few times. Okay, I'll have my fish scale on here that has the different numbers on it, right? And then I'll pull on here and I'll watch how many pounds or how many newtons I read. And that is the measurement of preload. In some instances, you'll also use torque. So for instance, if I yet again have this turned sideways, oops, if I have this turned sideways and I put a torque wrench of a known value and known reading on here, okay, I can find out if the preload is set correctly. Typically, it'll be that fish scale method.
So wouldn't the number that you get for making a turn, like it would matter the weight of the hub and stuff like that to make it turn? Like, so would there be like a value that you have?
So there actually is. That's a good point. They, when you're setting these, they actually sometimes give you different values if you have the drum on the hub or the wheels on the hub still, or if it's just the bare hub. But when you're measuring this preload, they know everything. So the only example that I know of preload is in your pinion shaft. The pinion shaft is the one that goes into the differential in your drive axle. So that is the only one that I'm aware of that you put preload on road. Are there other ones? Probably, like almost guaranteed. There's something that I didn't see an application, but that's the only one you're doing. And when you're doing that one, when you're measuring it, they actually know. So you're measuring the preload on a bearing that's on a shaft here, okay? They know the radius and the diameter of the component you're measuring. What you actually do is you do the same thing. You pull it and take your value, and then you calculate torque based on this distance here and this force, right? Because it's how many pounds and how many feet or inches on there, and I can get torque, right? They want you to figure that out and calculate that, and they already know how much this is, so they know what number you're looking for, and they know if you're within that range that everything's good, and if you're not, then something was misadjusted.
Thank you.
Sense? So for us though, for trailer axles that we're going to actually be playing with, tractor drive axles and steer axles, and in every case I've seen, and from all the literature from the manufacturers that I'm going to show you, you set your wheel ends to 1 to 5 thousandths end play, okay? And the last step we do before putting the hubcap on is going to be checking that end play, because it is crucial, very, very crucial. Different locking methods. So there's going to be different ways that we lock the adjustments into place, and we'll look at this in the next couple ILMs. The one is on wheel ends. We'll talk about the different, so there's tabs. So a lot of times you'll use a combination of these. So you'll use a washer with tabs and a lock nut, and then it locks the lock nut on. cotter pins, dowel pins, double nuts, all different kinds of ways. New ways are actually there's clips that hold them in place. Whatever we need to make sure that that bearing adjusting nut can't back off, it is very, very crucial. There's also a few that have tabs with locks that release. So I will be sure to show you all of these in the shop as well. Other than that, I talked about those seals a little bit. There's not too much difference. The main point of the seals, two things. Don't roll O-rings, lubricate them. That's how you don't roll them. And when it comes to seals, just like bearings, drive on the surface that is friction fit. That's essentially the gist of this. The proper tool to drive it in is the best one. Don't use sealants or gasket makers unless you're directed to by the manufacturer, okay? Other than that, this is all things we've talked about a little bit already, all right? So right now, I'm gonna go, it's 2:13. So you can take some time now. I haven't gone over any of the self-tests yet. I think I'm gonna save them and we'll do a bunch of them maybe near the end of the day, talk about the 2 or 3 that we haven't talked about yet, or maybe even tomorrow morning, okay? But for right now, take a look at the self-test, spend a few minutes doing it, take a 20-minute break at 2:20 and we'll come back at 2:40. Yes, we'll come back at 2:40, all right? I'm gonna stop recording now.
Okay.
Sounds good. So yeah, I'll see you at 2:40. I'm in